All right, let's get started. So welcome to ECE 5307. So I'm Professor Schneider. I'll be teaching the course. What I wanted to do today was go over two different sets of notes. One is just basically going through the syllabus. That's what this is. And then the second will be a very basic introduction to what machine learning is, different ways of thinking about it. And then next lecture we'll start to get into some of the real material for the course. So today is just a warm-up. So just to start at the beginning. So I'm the main instructor, but then we have two TAs. So is Kai-Ying here? Oh, here she is. Okay. So Kai-Ying wanted to.
Yeah, my name is Kai-Ying Xie, and I'm currently a fourth year PhD student in ECE. I'm starting some clustering problems, and I'm the TA for this course this semester, and I'll be mainly in charge of grading labs, and I'm also holding office hour in those times listed above: Wednesday 6:30 to 8 p.m., Thursday 4 to 8 p.m., and then Friday 11 a.m. to 1 p.m. So I will be holding office hour in meeting rooms located in Dries Lab 331. And at the same time, so I will have the Zoom room open, so you can either come in person or go to the Zoom, I guess, starting tonight. And so feel free to come in, ask any questions related to this course or any other questions related to machine learning. And if you have any problem going to the building, like during the late night, during the office hour, you can send me an email listed there to let me know. I will try to figure out how to let him get into the building or that meeting rooms. And I think that's all I have. Nice to meet everyone.
Okay, thanks, Kai-Ying. So so you can find this information here in these slides. I think I also posted this. So it's also in the syllabus, which is on Carmen. Maybe it made it to an announcement as well. Kai-Ying is going to be holding most of the office hours, and as you can see, a lot of them are in the evening, which is a pretty good slot for a lot of you who have different course conflicts during the day. But we have some, in the morning and so on. Basically, the homeworks will be due Friday at 4 p.m. Every week, you should expect a homework, and there will be a lab due every week at midnight on Friday, and there will also be a quiz on Friday that's going to be a short, 5-minute multiple choice Carmen quiz, maybe 7 minutes, something like that. So these office hours are kind of set up for that. Friday is the main date where everything is due, so we have a lot of office hours just leading up to Friday. Yes?
Is the quiz on your own or in class?
Quiz is on your own. You can take it any time just before the deadline, which I think is, again, 4 p.m. Friday, of the week after we cover the material. So once we cover the material, the following week, you get a chance to learn about it more on your own through homework in the lab. And at the end of that week, when everything is due, that's when the quiz is due. Okay? And then we have also a grader for the homework, Abigail. I don't think Abigail's here, but she's going to be grading the homework, but she's not going to be holding office hours. If you have a question on the specific homework grading, please email her. If somehow you can't get that resolved with her, you could bring me into it, but hopefully you can get most of your issues with homework grading resolved with Abigail directly. I will also be holding office hours on Thursday for a couple hours, and I'll also try to hold them both in my room in person, but also over Zoom in case you can't physically be there. Okay, so basically what this course is about is understand what machine learning is, various forms of it, things like regression, classification, clustering, dimensionality reduction. And that understanding kind of comes in two forms. One form is mathematics, understanding the math behind standard models, algorithms, and methods. And so this is going to be building on concepts from linear algebra, probability, and statistics. But then also, we don't want you to just learn math. We want you to actually be able to implement this stuff. And so for that, we want you guys to gain a lot of experience with standard coding tools, Python-based packages like NumPy, scikit-learn, Jupyter, Matplotlib, and then for deep learning, PyTorch. And then in terms of how you're going to turn in your assignments and your project at the end, it's going to be using GitHub, which is also the way that almost all machine learning code is disseminated today. If you want to go download code for machine learning, it's going to be on some GitHub page. So it's good to get familiar with GitHub if you're not already used to it. Okay, stop me at any time if you guys have questions. So in terms of prerequisites, so if you're an undergrad, you're restricted to be an ECE major. If you're a graduate student, you can be from any major. This course is not going to be ECE specific though. The restriction to the ECE major was just something that CSE forced us to do because they were being territorial about machine learning. So, but there's nothing like ECE specific in this course. Okay, in terms of the prerequisites, so these are kind of like the three pillars. So you have calculus and linear algebra. Super important. Linear algebra is something that a lot of students tell me that they struggle with. And so, but it's so important to this course that if you simply don't know your linear algebra, you can't really take in much of the knowledge about machine learning. So in response to that, a few semesters ago, I started assigning a homework 0, which is not material that I'm going to cover, it's just material that you're assumed to have taken in a previous course. That homework 0, this term is due on Monday. So it's something that you can start immediately. You could have started a few days ago when I posted it, when I emailed you, all that stuff. And there is a nice, pretty concise review it comes from Stanford, of all, because I don't want you to go and feel like you have to read a book on linear algebra. No one has time to read a book. But this handout is just a few pages, and it summarizes all the important concepts that we need for this course. It's not very deep into linear algebra. It's just some fundamentals, but those fundamentals are super important. So I don't know what happened.
Fall asleep.
Okay. So, okay. So that's most of that. And a big part of machine learning is also probability and statistics. Again, you don't really have to know that much. This kind of stuff that you would take as an undergraduate in an ECE or engineering type program should be enough. And when we start using it, when we start getting more involved with it, I will add I will review stuff during the lecture and stuff. So there's not like a homework 0 for this stuff. We won't use it immediately. We'll start using it gradually in lecture, unit 1 and so on. Okay, and then in terms of programming, like I mentioned before, the course is going to be taught using Python, but I don't expect you guys to necessarily know Python already. You just need to know some basic scientific type programming. So it could be C++, it could be, I think Java is fine, it could even be MATLAB. Because the stuff we're doing is at a pretty high level, and as long as you know how to program, you can take whatever language you know and you can basically port it to Python. And there will be a lot of demonstrations interspersed in the notes, and also you can download the code that will give you examples of how to do all this stuff in Python. So I haven't had any students in the past tell me that this has been an issue. This seems like pretty easy to learn the kind of Python that we need to use in this course, even if you haven't had it. How many of you guys have had experience with Python? I'm curious. Okay, almost all of you, which is great. But if you haven't, it shouldn't be a big deal. Okay, so I don't even know if the university is still doing online courses or not, but this course is in person, obviously. And I expect you guys to come to lecture. I'm not going to take attendance, you're adults. I understand that sometimes maybe you can't make it because you have something else going on. But I will be recording these lectures and putting them up on YouTube. So even if you come to lecture, if you feel like you wanted to go back and listen to what I said again, you will have that opportunity. Or if you can't make it, you'll have that opportunity to watch a YouTube video. In fact, you can find all the videos from last semester already on YouTube. If you want, for some reason, to hear me say it a different way, I'm sure it will be a little different. Or peek ahead, you can do that, of course, if you want. Everything's there, it's public. So what I'm going to do is go through notes like this. And so the video on YouTube is just, you'll be seeing basically what's on the screen. You'll be seeing my pen and so on. There are some blanks in the notes. I think it's really useful if you guys have a copy of these and if you take notes during lecture, because otherwise what happens is if you're not actively following, it's easy for your mind to wander. It's easy to get distracted, maybe even fall asleep, although with this temperature, maybe you won't fall asleep, but it's much, much better for this class or any class if you can be engaged. And just like writing stuff down in the margins, that helps you to stay engaged. And I think it just helps to get the information in your head a lot easier than just sitting back and doing nothing. Yes?
Where are these going to be posted on the current page?
So all of the lecture material is actually on GitHub.
Oh.
And if you go to Carmen, there was some announcements that describe the procedure that you need to get onto GitHub. So it's a tiny bit convoluted, but there's no other way I know how to do it. So you basically just go through a few steps, and eventually you get onto GitHub, and you can see all the stuff in the main course repository, which is going to include all of the lecture notes, PDFs, as well as all the coding examples, as well as a whole bunch of other sort of miscellaneous materials on using GitHub or various things that will be useful throughout the course. So please follow those directions sooner than later. In fact, that linear algebra review that you need for homework 0 is on GitHub. So it's kind of my way to force you to try to do that procedure now rather than waiting until the first lab is due. Okay. So we already talked about office hours. Another thing I use in this course are Carmen discussions. So I don't know if you've used these in previous courses, but Carmen has these discussion pages, and I find them very useful as a way of answering questions. Because what often happens is when one of you guys has a question, it could be on a homework topic, on a lab, on a lecture, several other people have the same question. So rather than responding to 10 of the same email and then having a delay because I'm busy doing other things, if you could post your question to the discussion board, you might find that another student can answer it immediately. Especially when it comes to coding, sometimes you guys do really weird little things that it's very hard to spot from looking at your code, but maybe some other student has done it and you get some weird error and someone will be like, oh yeah, this is the reason why, because you've left out this little thing. And they can respond to you much quicker than Kai-Ying or I can. So the discussions work really well. And you guys are encouraged to respond to your peers and to try to answer the questions yourself. And and I'll jump in there if needed, but it's meant to be interactive. Okay. Of course, if you have a personal question, send me an email. Okay, so in terms of grading, there's basically 5 components to this course. There are what I'll call analytical homeworks. These are like traditional homeworks where you derive little things and so on. Sometimes there's a little bit of coding for them, but not involving a data set and so on. And then we have coding labs, and those coding labs will all involve some data set and then doing some machine learning with that data set. And again, weekly homeworks due Fridays at 4 p.m., labs due Fridays at midnight, weekly Carmen quizzes, multiple choice, 5 questions usually, and those are meant to test just understanding of concepts from the lectures. So some people tell me, I understand all the concepts, I just have a hard time expressing it in math on the homework or the exams. Okay, so you have the quizzes that you can show your knowledge on. We also have 2 midterms, which will be given in class. These are the tentative dates. And those are going to be traditional midterms. not coding stuff, but conceptual and mathematical. And then finally, we're going to have a final project at the end of the term, which is I'm going to give you a data set, and I'm not going to tell you where the data comes from. It'll just be a data set, and your objective is to program different methods on that data set and try to compete and do the best among all your peers. So there's going to be a Kaggle contest. Kaggle is a typical way that people have contests with machine learning. And so you guys, there's a leaderboard. You'll see where your score is. And I find it's really fun. Students get really into it, into like trying to, outdo everyone else. There will be teams of 3 people. And you can choose your partners, or if you don't know people, or maybe you just have 2 of you, we can form the rest of the team for you. We won't need to worry about this until about halfway through the term, but just keep this in mind. So I'm not going to give letter grades for any of this stuff. You're going to get on an exam, I'm just going to give you maybe there'll be 50 points total and you score, 35 or whatever it is. But at the very end of the term, we have to map everything to letter grades. So you're going to have a cumulative score, which is based on all of this. And then I'm going to have to do some curving, some mapping to letter grades. And I'm going to do that differently for undergrads and grads. And if you want to know at any point, how are you doing in the course, histograms. I'm going to be posting histograms. So you'll see among all the undergrads, this is the homework histogram. This is the lab histogram. This is the exam histogram. This is the quiz histogram. And you can see exactly how you're doing. At the end of the term, your letter grade will basically be relative to your peers. Okay? Any questions on anything so far? Okay. Final project, I mentioned before, the goal is to apply machine learning concepts that you learned in this class, not things from outside. You'll be given a data set, and you'll be saying this is like a classification problem. And you'll just have to use all that you learned throughout the term, make smart decisions, code it well, and do as good as you can. So in addition to submitting your code, you'll have a written report that just kind of says, this is what we tried, this is what we found, just kind of convince me that you understand what you're doing. You made good decisions. Okay. There's no official textbook for the course. I'm just going to be giving my notes out, but if you want books, these are a few I can recommend. The first one is a really nice book in terms of all the theoretical concepts, but it's written more like from the statistical community. Statisticians, they use R, not Python, so the coding examples are not so useful. If you want a book that's just about Python for machine learning, one of the previous TAs told me that she really liked this one. There's probably other good ones as well. But this book has no theory or concepts. It's just purely about the Python. This third one here is kind of a nice blend between concepts and Python. But in terms of deep learning, we're going to be using PyTorch, and I think this book uses Keras and TensorFlow. So for PyTorch, which we won't get to for a little while, this is kind of the PyTorch book written by the authors of PyTorch, and it used to be free. If you search around in Google, you can find a free PDF and download that. Otherwise, it's like $20 or something, and that's what we're going to use for deep learning. Okay. Any questions? Okay. So in terms of how and where the materials will be found, so Carmen Canvas is going to be used for course announcements, discussion boards, homework, so you'll find your homework assignment there. You're going to submit all your homeworks electronically as a PDF. And then the grader for homeworks, Abigail, she'll just be able to grade them directly and submit them back the graded ones to Carmen, and you'll be able to see, how you've done. You'll also find solutions and histograms for homework there. In terms of labs, you will find a link. You just click on the link and it will take you to GitHub, and it will basically GitHub will make a repository just for you, and the people who have access to that are you and me and the TAs for grading, but you won't have access to each other's, obviously. You'll also find solutions and histograms to the labs on Carmen. Quizzes you'll find there. Exams, we'll post solutions and histograms there. Final project, you'll find some information, but you will submit the final project, again, using GitHub, but as a group. And you'll also find all your grades and stuff on Carmen. So on GitHub, lecture PDFs, demonstration code, which are going to be in Jupyter Notebooks. Talk about that in a second. Labs, final project, repository submissions. And this is the primary course repository here. This is private in the sense that the public can't access it, but once you go through those steps on Carmen, you can access it. And in fact, in all of my notes, whatever is green is a link. So like this is a link, and let's see. So if I click on it, you'll see it will go, okay, so you have to sign in order to get access and stuff, but once you have access and you're signed in, it will take you right there. So one thing about GitHub is that it's you can see the code there, but you can't run the code there. In order to run the code, you need to get that information onto your local machine. So you need to basically create a copy of that repository. That's something we call pulling it. So you pull it down, and then throughout the term, I might be making small modifications to things, like if there's a mistake in a lecture, I'll correct it. And so if you want a refreshed copy, you can pull down and get the latest updates at any time you want. And so that's all those instructions you can find. You can find all this online in the course materials. And then basically the way that you do the labs is a repository will be made for you. You bring that down to your local machine. You complete the rest of the code. So you'll be given a skeleton of the code, and you complete the rest of it. Once you're done, or as many times as you want, you can push it back up to the cloud, and then the TAs and I can see it. So that's how the labs will be, and the projects will also be graded. Okay, Python. Why are we using Python? It's a general and powerful language. It includes many machine learning libraries, especially for deep learning. It's kind of like the de facto code for deep learning. And it's free and open source, unlike things like MATLAB. In terms of prerequisites, like I mentioned before, you don't need to know Python. I'll teach it to you. You do need to know some basic programming. And object-oriented programming is very helpful because there are object-oriented concepts that will come up a lot. And so if you look at the primary course repository, you'll find tutorials on the basic use of Python and NumPy, which is kind of like the main numerical package for Python. I put in some links, like if you feel like you're an expert in MATLAB and you don't know Python, there's some links or blogs and stuff people have written as to how to do that, make that leap. And I also posted some practice materials for Python and NumPy because sometimes students say, yeah, I want to learn, I want to be better, what sources do I have to practice? And this would be outside the course, just if you wanted to do this on your own. Some more details with Python. We're going to be using Python 3, not Python 2. We're going to be using, so NumPy I mentioned is more like just the numerical library, a lot of linear algebra stuff. Scikit-learn has basic kind of classical machine learning stuff. PyTorch is for deep learning. And Jupyter Notebooks are a nice way to code and show the results of your code. So we'll see some examples soon. You can run Python on your personal machine, laptop, or whatever, or you can run it in an OSU computer lab. If you don't have it already installed on your machine, I recommend the Anaconda distribution. And I should just say that what we do in this course will not require huge computational resources. It's not like you need massive GPUs and stuff. When it comes to the project, some of you may wish that you want to try more things, train more models. At that point, you might want to look at ways to increase your power. So there's ways to do that. Basically running GPUs in the cloud, and there's various ways to do that. I'm not going to get into the details now, but that's something you might want to do towards the end of the term. So this is what a Jupyter Notebook looks like. This is just a screenshot of one, and basically it's sort of a mixture of text and code. And when you run this code, it outputs this, so you can kind of see the results of running the code. So that way I can show you what code looks like without actually running it. And you can see all this on GitHub. Now, if you actually want to rerun this and try what happens under a different random seed, then you need to actually bring it down to your local machine to do that. Okay, so there's in what I call Unit 0, which is this introductory day, there's some very basic stuff on NumPy, 2 different demos on how to work with NumPy. And yeah, so that's just kind of, again, covering mainly the syllabus. Any questions on any of this? Yeah.
Collaborating in terms of like homework and stuff, what's the policy on that?
Yeah, you're definitely welcome to collaborate with other students. I just want to make sure that whatever you turn in is your own work. So meet with people, discuss it, but we shouldn't have situations where there's like an exact copy where someone else does it and then someone else copies it and just turns that in. Because obviously you don't learn very much. The whole purpose of all the homework and labs is just learning, right? So if you find your way around the learning, then you kind of just shortchange yourself. So that's the issue. But definitely, yeah, I think it's really productive to talk things over with people. With the labs especially, you might run into a bug and talk to your peers and see if they had the same bug, or if they see what you can. Because sometimes these bugs can be kind of tricky. You can kind of feel stumped. Google searching is really good for bugs too. If you're getting a specific error, Google search it. You often find something useful that is like a clue to what it might be from. Okay. Yeah.
My computer is still delivered, so can I use the computer in the memory?
Yeah, you can use, like I mentioned here, you can use like the OSU computer labs. So I know that, or at least a couple years ago, the computers in Dries had Python installed, but if you go far outside, they may not. You might have to install it yourself. Another question?
Yeah. You said in the repository, you said we're each going to have our own little section to upload our stuff. Is that
So
for
for every lab, a repository will be created for you.
Oh,
Yeah, different one for every lab.
so it's not on requirement yet. I mean, you said
That's on GitHub.
Oh, excuse me. Yeah.
Yeah.
GitHub. But it's not there yet.
It's clicked when you click on the link for the lab. It just GitHub creates that, and it lives in the cloud somewhere. And then you basically pull it down to your local machine. You modify it and you push it back up to the cloud, and then the TA can bring it down to her machine. She can grade it there. That's how it works. Any other questions? Great. Okay.